Do you suffer from migraines? It might be a sign of metabolic dysfunction. Studies show migraines are linked to insulin resistance and poor mitochondrial function, meaning your brain isn't getting the steady energy it needs. When your brain can't use glucose properly, things get chaotic. Neurons become overactive, inflammation increases, and your risk of migraines goes up. This is where ketones can help. They bypass the broken glucose system, fuel the brain more easily, control oxidative stress, and reduce inflammation. In fact, some research shows that ketogenic diets and ketones can reduce migraine attacks by up to 80%. If migraines are a part of your life, it might be time to look at your metabolic health. This is lecture 115 of the Metabolic Classroom. Looking to improve your own metabolic health? Visit insuliniq.com for courses, coaching, consultations, and a 10-day free community membership trial. To dive deep into the science behind metabolic health, become an insider at benbikman.com, where you'll enjoy my exclusive content, ad-free podcasts, live stream Q&A access, and more. Welcome back to the Metabolic Classroom. I'm Ben Bikman, biomedical scientist and professor of cell biology. Today, we're exploring a topic that's close to home for millions. That is migraines. But no surprise, I'm framing this through the lens of metabolism. This is actually a topic that's increasingly termed metabolic psychiatry. And in this case, we're focusing on how disruptions in the energy systems, like insulin resistance and mitochondrial function, play a key role in how the brain works, and then that manifesting into disorders that fall within the realm of psychiatry. Now, during the mini lecture, after defining migraines, I want to make sure you understand how insulin resistance plays a part, of course, touching on the mitochondrial connection, and discussing how ketones in the ketogenic diet might offer relief. I think you'll be fascinated to learn how old the evidence for this really is. One lesson from today's mini lecture is that studying metabolism is more than just losing weight. It's also the foundation of how our brains function. In psychiatry, there's an increased focus on looking at metabolic disorders as an underlying condition or foundation for many brain conditions like depression, anxiety, and yes, migraines. Now, I'm not a psychiatrist, I'm a metabolic scientist, but again, these two realms are coming together in a pretty fascinating and helpful way. First of all, what exactly is a migraine? A migraine isn't your average headache. It's a complex neurological disorder characterized by recurrent attacks of moderate to severe throbbing or a pulsing type of pain. And it's usually going to occur on one side of the head. These can last from hours to days, and they're frequently accompanied by other physical symptoms like nausea, vomiting, and extreme sensitivity to light, sounds, or smells. For some, there's an aura phase beforehand. This is things like visual disturbances like some flashing lights or blind spots, or even sensory changes like tingling in the limbs. Migraines are surprisingly common, affecting up to about 15% of the global population, with women being about 3 times more likely to experience them. And we'll explore why in the unique role of estrogen in just a bit. But here's where metabolic psychiatry comes in. Migraines aren't just triggered by stress or chocolate, although that's more interesting and relevant than you might think. They're deeply tied to how our bodies handle energy at even just the level of the cell, the very neurons in the brain. To really understand migraines in a metabolic context, let's break it down further. Migraines involve various distinct phases. The prodrome, which is kind of the early warning, which can be manifested in a mood change or a food craving. Then there's the aura. Then there's the attack itself, and then what's sometimes called a postdrome or a hangover, if you will. Metabolically, this ties into energy fluctuations. Think of it as your brain's power grid short-circuiting. To weave in the metabolic angle even deeper, consider the brain's glucose transporter, specifically GLUT4. That is the insulin-dependent transporter found primarily within the brain, at least, neurons that are in regions of the cortex, the hippocampus, the hypothalamus, and to a lesser extent, even the astrocytes, which are cells that support the neurons I just mentioned. These cells rely at least partly on insulin to shuttle glucose for energy. Thus, it's no surprise that insulin resistance can exacerbate the glucose movement by causing some, in the end, resulting in some erratic glucose delivery, leading to neurons that are just not firing properly because they're not fueled properly. In fact, a paper published in 2018 that looks at insulin resistance directly connects insulin resistance to increased migraine risk, where chronic high insulin promotes brain inflammation and actually sensitizes pain pathways within the brain as well. And I'll actually come back to that when I mention and discuss the metabolism and the relevance of serotonin. One way I've described the brain before is that it's a gas guzzling high performance engine. It consumes about 20% of your body's total energy, even though it's only about 2% of your body weight. And when that energy supply falters, no surprise, the engine begins to sputter. All right, now that you have an understanding, a general overview of migraines and energy relevance and fuel use, let's look at insulin resistance because it's surprisingly relevant. Studies show a very strong link between insulin resistance and migraines, especially with chronic frequency. In people with ongoing migraines, insulin sensitivity is often impaired, and this resistance correlates with higher migraine frequency and severity. One noteworthy study from about 10 years ago examined women with chronic migraines and found that insulin resistance was significantly higher in this group compared to controls, suggesting there's an exacerbating connection here with disrupted glucose metabolism in the brain. Another review highlights how insulin resistance might bridge migraines to comorbidities, things like obesity, depression, and even cognitive impairment like early stage Alzheimer's. This collectively paints migraines as part of a broader metabolic syndrome. In essence, when your brain can't efficiently use glucose due to insulin resistance, it creates an energy deficit that lowers the threshold for migraine attacks. In other words, it's just that much easier for the brain to start firing in such a way to cause a migraine when the metabolism is disrupted. There are very well-known triggers, and one of the most common is something like a high-carb binge. It can very much worsen this problem. The fluctuating blood sugar amplifies neuronal hyperexcitability. This is real. For example, there's a 2020 study that I have in the show notes that found that monitoring via blood glucose monitoring, that when people experienced a spike in their blood glucose levels, and this was coming from a carb-heavy binge or sugary snack, it directly preceded attacks linking hyperglycemia to the onset. So really as close as you can, establishing some causality. Reviews of the research echo this. High glycemic foods like sweets trigger migraines in many, while low glycemic diets, as I'll get to at the end, really stabilize blood glucose levels and will reduce the frequency. So there's something to be said for the volatility of glucose levels in the blood on a typical high-carb diet that acts as a more frequent trigger for migraines. Now, beyond the energy deficits, insulin resistance disrupts serotonin signaling, which is a key neurotransmitter for mood and pain regulation. And I mentioned enhancing the sensitivity to pain just a moment ago, and this is where it becomes relevant. When insulin signaling is working well, that is to say in ideal insulin sensitivity conditions, insulin will enhance serotonin production, and it will then promote the brain's uptake of tryptophan, which is a key precursor to the neurotransmitter, to serotonin. And it does so by clearing competing amino acids from the bloodstream. So amino acids that would be fighting against tryptophan to get into the brain, when insulin's working well, it's enhancing tryptophan's ability to get in. The result of this is that we have a more optimal serotonin production and level to help regulate mood and pain perception and even the threshold for a signal becoming a full-blown migraine. Now, there's a reciprocal direction to this as well, where serotonin can also fine-tune insulin secretion from the pancreatic beta cells during glucose spikes. So that means that as much as insulin's regulating serotonin secretion, serotonin in turn is influencing how the beta cells are responding to glucose loads and improving overall insulin sensitivity. Underlying all of this are the comorbidities like obesity. Insulin resistance links migraines to obesity, where excess adipose tissue releases pro-inflammatory cytokines, which can compromise insulin signaling, as inflammation is one of the cardinal causes, not to mention the potential stress on mitochondria and oxidative damage. Another important study that I relied on in putting all this together is a paper published in 2020 that found that in overweight migraineurs, so people who experience migraines, they found that improving insulin sensitivity with lifestyle changes reduced attack frequency. It reduced the frequency of migraines by about 50%. And importantly, this was independent of weight loss. So it's not that they had to lose weight in order to get this benefit with migraine frequency. It happened without weight loss. So this highlights insulin's direct role in all of this process. Now, a couple times I've mentioned that women are more susceptible to migraines than men. One reason women may experience migraines more often is due to estrogen fluctuations. Now, I'm going to say estrogen because that's the hormone you're used to hearing. The main estrogen is estradiol. So while I say estrogen, just for the sake of ease and familiarity, you could be thinking estradiol. Estrogen fluctuations throughout the menstrual cycle, pregnancy, and menopause do play a very important role in migraines, with drops in estrogen levels acting as a very relevant and real trigger for an attack. This, if you will, an estrogen withdrawal, when estrogen levels drop, even if it's cyclically, like during the course of a menstrual cycle. But the estrogen withdrawal hypothesis explains why many women experience migraines right before their period or during perimenopause, where the falling estrogen sensitizes the brain to pain. It can disrupt blood vessel diameter and blood flow. It can lower serotonin levels, which amplifies pain sensitivity, and even having an increase in inflammation, as estradiol elicits an anti-inflammatory signal as well. But even here, interestingly, but perhaps not surprisingly, this can still tie back to insulin resistance because estrogen enhances insulin sensitivity. Thus, its loss can drive more insulin resistance. I'd like to think that understanding this can help tailor interventions that we'll end on in just a few minutes. But anything that can stabilize estrogen and stabilize insulin can then stabilize glucose uptake. It can then stabilize glucose uptake and ultimately ease the burden and frequency of migraines, of course, especially in women. Now, let's shift to mitochondria, because why does the energy crisis hit the brain so hard? Well, remember, the brain is an energy hog. It has a very high demand for energy. And the mitochondria are very important here. These little organelles within the cell generate something called ATP, which is the energy currency that neurons and all other cells rely on. Now, just as a point of interest, whenever you hear someone like a wizened old professor describe ATP as an energy currency, what I mean by that, when I use that term, is that the cell needs to give, it needs something in order to get work done. Whatever the cell wants to do. In the case of a neuron, it wants to send a signal down the length of itself, sending the signal from one spot to another spot. Well, in order to get that work done, it needs to buy it, if you will. And ATP is the currency, if you will, another if you will, that the cell will use to get that work done. Now, in migraines, mitochondrial dysfunction is a recurring theme. Research is quite clear that people with migraines often have impaired mitochondrial function, leading not only to reduced energy production, or ATP production to be more precise, but at the same time leading to more production of reactive oxygen species, or ROS, or ROS. These, of course, are very harmful free radicals that can damage everything in the cell, membranes, DNA, and everything else. The oxidative stress can trigger cortical spreading depression, which is a technical term for the wave of neuronal hyperactivity. that you can see that underlies migraine auras and pain. A 2022 comprehensive review paper emphasized that mitochondrial abnormalities contribute to the brain's energy deficit in migraines, making neurons more vulnerable to triggers. In fact, even genetic studies show links between mitochondrial DNA variations and migraine susceptibility. So, in other words, they could actually look at people's genetics of the genes within the mitochondria and begin to predict, if you will, who would be more likely to experience a migraine. Now, even though I haven't mentioned it for a few minutes, and I hope you can respect that, the restraint from my part, insulin resistance still is relevant here and it compounds this process. We have an impaired something called mitochondrial biogenesis, or the creation of new mitochondria in insulin resistant cells. In fact, what I'd like to think is very interesting work from my own lab shows that high insulin levels, through some intermediate steps that I won't get into right now, increases or forces mitochondrial fission. So this is forcing the mitochondria, which are these long network connected organelles. It forces them into much smaller, distinct pieces, which are less functioning when it's forced. So in this realm, again, of metabolic psychiatry, addressing mitochondrial health, it really isn't optional. You need to, in order to understand a key part to breaking the migraine cycle. Now, discussing insulin and mitochondria makes me have to bring up ketones. And that is a good time to transition just generally into solutions, if you will. First of all, evidence suggests that anything that improves insulin sensitivity will improve migraines, reducing the frequency and severity. For example, even just modest lifestyle tweaks like regular exercise have been linked to fewer migraine attacks. Pharmacologically, there are not many drugs that actually improve insulin sensitivity. Let me just repeat that, if perhaps in another way. Many of the so-called metabolic drugs or anti-diabetic drugs actually just lower glucose, sometimes even by making insulin resistance even worse. So the actual number of insulin sensitizing medications is very, very small. Metformin is perhaps the most famous. It's one of the very few. A 2020 clinical trial found that 500 milligrams twice daily of metformin reduced migraine frequency and severity, comparable to more well-known standard drugs that are used, and so perhaps with fewer consequences, which is something to consider. Although that's not to say metformin does not have consequences. Remember, something I've discussed in previous episodes, there are considerations to metformin, particularly when it comes to people who are exercising. Those two do not mesh together very well. And ironically, I just included them in the same series of statements. All right. Now, of course, if glucose metabolism is part of the problem, what if we flip the switch to the alternative fuel? In fact, I call it the brain's preferred fuel, and that's where ketones come in. Ketones are molecules that the body is going to produce when we're breaking down a lot of fat. When we're metabolizing fat through beta oxidation, the actual burning part or the breaking part of the fat molecule, the fatty acid, we're going to increase the likelihood of making ketones. So, of course, this is going to happen during fasting or the long-term consumption of a low-carb diet. But it can only happen when insulin is low. What those two things have in common, eating low-carb or not eating anything, is that insulin is low. And when insulin's low, ketogenesis, well, even prior to that, lipolysis and fatty acid oxidation, and then ketogenesis are all disinhibited. In other words, we're removing the brake, allowing them to occur. Now, unlike glucose, which requires insulin to enter cells, ketones can bypass that pathway, those restrictions, and provide, if you will, an uncomplicated fuel for the brain. In migraines, ketones show a lot of promise by stabilizing energy supply and even reducing inflammation. Ketones are very well known to enhance mitochondrial function by increasing ATP production per unit oxygen consumed and lowering ROS generation, lowering the production of these reactive oxygen species. So this directly can counter the dysfunction that I'd mentioned earlier. Ketones also inhibit excitotoxicity, the overexcited neuron firing that can modulate pain pathways. In fact, one of the papers, again, that I've relied on here is a 2019 review that outlines many mechanisms, but detailing ultimately that ketones like beta hydroxybutyrate improve brain energy metabolism, reduce oxidative stress, and influence even other things like mitochondrial dynamics, the fusion or the fission or the separating. All of this, of course, contributes to a heavy improvement in migraine frequency and severity. Now, this does lead me to the ketogenic diet a little more heavily, the classic high-fat, low-carb eating plan. Modern studies suggest it can slash migraine frequency by up to about 80% in some cases. But what I like to do very often as a scientist is look at the history of a particular scientific topic. So let's honor the pioneers, if you will, in this realm. The ketogenic diet's roots trace back to the early 1920s. This is initially the earliest work that we have evidence on, although there's evidence of ancient things like fasting being therapeutic even in this regard. But in the modern era, it'd be the early 1900s, developed at the Mayo Clinic, particularly for epilepsy, but they found very soon after that it also helped with migraines. So this is still in the early 1920s. So one of the earliest papers, in fact, that I'm aware of, in fact, it's the earliest that I'm aware of, was published in 1928. It's titled "An Experience with a Ketogenic Dietary in Migraine." So again, it's sort of funny wording here. An experience with a ketogenic dietary in migraine. The diet was typical ketogenic, high in fats, like fatty protein sources like eggs and fatty meat, butter, cream, moderate protein. They didn't identify the amount, and very, very low carb. So a 50-gram restriction. And this was just to ensure ketosis. Ketosis was confirmed in these patients, and they followed it for weeks to months. And it was this would be called more accurately a case study, because the clinician was just following these people. But the results are profound. About half of the individuals in this study, or this case study, experienced some relief, with about a quarter of them seeing a complete remission. So their migraines stopped completely. And what's interesting about this study, and I encourage you to look it up, it actually was pretty specific, where it's even identified a timeline where it would say something like subject 2 had a migraine for the 2 migraines that first week and has never had another since. So things like that. But in this work, it's interesting that they noted that the results were best in those with metabolic irregularities like obesity. That, of course, foreshadows today's understanding of the relevance of insulin resistance, I believe. Now, building on that, another paper was published in 1930 in the Journal of the American Medical Association entitled "Migraine: Results of Treatment by Ketogenic Diet in 50 Cases." So this included 50 adults with typical migraines, and they used a similar ketogenic regimen, although they were a little clearer about it. 10 to 20 grams of carbs, 1 gram per kilogram body weight, and then fats making up all the rest, often into the low hundreds, up to 300 or more grams of fat daily. Ketosis was confirmed in the study. Now, impressively, attacks were completely controlled in 14 patients. 25 more were definitely improved. And so the sum is about 80% of the individuals had very positive outcomes. So at the time, interestingly, the clinicians attributed this to stabilized blood sugar and reduced neuronal irritability. And they did this because of parallels with epilepsy, but it still is shockingly predictive and accurate. Now, these century-old efforts shifted the thinking at the time to a metabolic focus. They were rudimentary. It was not a randomized controlled trial, but they nevertheless do align with what we know today. Ketones reduce inflammation and support mitochondria, increasing ATP, reducing oxidative stress. And thankfully, as much as we have these data, they were unfortunately overlooked for decades. But it's a perspective that now has never been stronger and is reaching new heights. And indeed, fast forward to now, and we have something like a recent meta-analysis of 10 studies confirming that ketosis, whether from diet or supplements, and more on that in a moment, will reduce the number of days with a migraine, reduce the severity, and reduce the intensity. A note A notable study was one published in 2019 where 1 month of a ketogenic diet in about 100 patients led to that dramatic and consistent. Now we've seen this about an 80% reduction in attacks. So this definitely leaves room for there being non-metabolic, or at least not identified metabolic, but maybe even non-metabolic origins to migraines. And I want people to appreciate that. Anyone listening, I've never wanted to suggest that disruptions to metabolism like insulin resistance and mitochondrial dysfunction are a cause of every chronic disease, but it is such a common one that I've believed very firmly it's worth pursuing. So what does this all mean for you as we wrap up? In metabolic psychiatry, migraines are a signal, I think, to check your metabolic health. If you're getting migraines, test for insulin resistance, get a fasting insulin, and or get your HOMA IR score. You could also look at some smart supplements to support mitochondrial health, like CoQ10 or riboflavin, and absolutely consider ketones. You can certainly try a ketogenic diet, which again, there's 100 years of evidence to support this, or anything that's going to improve your insulin sensitivity by way of a dietary intervention. If you'll pardon me for saying this, I encourage you to check out my website, insuliniq.com, as a helpful resource if you want to try that route. Of course, there's an easier route, which is just exogenous ketone supplements. That might be a nice way to just test whether a metabolic intervention actually helps with your migraines, because it's something you can do immediately. If you do try that, I strongly recommend actually getting beta-hydroxybutyrate or BHB itself, whether it's in a ketone electrolytes or a real ketone form, sometimes termed a BHB acid. But anything with GoBHB is going to be a very solid choice in that regard. So to now fully conclude, more than the pain, with migraines, they are, if you will, the brain's early signal that there is a metabolic problem. By addressing insulin resistance and enhancing mitochondrial function, and I would even say harnessing the value of ketones, the brain's affection for ketones, you can, I believe, really reclaim control of your brain health and migraines. To some degree, this is something we've known for about a century. Thanks for joining me on the Metabolic Classroom. Please let me know your experiences in the comments if this is something you've had some experience with. Until next time, more knowledge, better health. Looking to improve your own metabolic health? Visit insuliniq.com for courses, coaching, consultations, and a 10-day free community membership trial. To dive deep into the science behind metabolic health, become an insider at benbikman.com, where you'll enjoy my exclusive content, ad-free podcasts, live stream Q&A access, and more.